Chapter 12 Areas and Volumes of Solids by June Moon, Andrea Labutsky, Ryan Choi, and Jesse Summers. 12.1 Prisms. A prism is a solid geometric figure whose two bases are similar, equal, and parallel. An altitude is a segment joining the two base planes and is perpendicular to both. Lateral faces are the faces of a prism that are not its bases. Lateral edges are parallel segments conjoining lateral faces. A right prism is a prism in which lateral faces are rectangles, and an oblique prism is a prism in which lateral faces are not rectangles. The lateral area of a prism is the sum of the areas of its lateral faces. The total area of a prism is the sum of the areas of all its faces. The formula for total area is lateral area plus the areas of the bases. Theorem 12.1 states that the lateral area of a right prism equals the perimeter of a base times the height of the prism. This can be shortened by lateral area equals pH. Theorem 12.2 states that the volume of a right prism equals the area of a base times the height of the prism. Also, this is denoted by V equals the area of the base times H. Now let's try an example. Example 1. A right trapezoidal prism is shown. Find the A, lateral area, B, total area, and C, volume. The answers to these are A. First find the perimeter of a base. The perimeter equals 5 plus 6 plus 5 plus 12, which is 28 centimeters. Now you use the formula for the lateral area. Lateral area equals perimeter times H, which equals 28 times 10, and that equals to 280 centimeters squared. B. First find the area of a base. B equals 1/2 times 4 times 12 plus 6, which is equal to 36 centimeters squared. Now use the formula for total area. Total area equals lateral area plus 2 times the area of a base equals 280 plus 2 times 36, which is equals to 352 centimeters squared. Now for the last part, C. Volume equals the area of a base times H, which equals to 36 times 10, which is 360 centimeters cubed.
Hey guys, this is June Moon here. I'll teach you about 12.2 pyramids. The vertex of a pyramid is the point where the lateral edges meet. The base is the bottom face of a pyramid. The altitude of a pyramid is the perpendicular line going from the vertex to the base. The lateral faces of a pyramid is the triangular faces with the vertex in common. All the lateral faces are isosceles triangles. Lateral edges of a pyramid is the segments that the lateral faces intersect in. Slant height of a pyramid is the height of a lateral face. Let's do an example. Example 1. A regular square pyramid has base edges 10 and lateral edges 13. Find A, its slant height, and B, its height. Solution to the example. A. Use the Pythagorean theorem. In right triangle VMC, slant height equals square root of 13 squared minus 5 squared equals 12. B. In right triangle VOM, H equals square root of 12 squared minus 5 squared equals square root 119. 12.2 continue. Method 1. Find the area of one lateral face and multiply by n. N is the number of lateral faces. Method 2. Use the formula lateral area equals 1/2 perimeter times the slant height, stated as the next theorem. Theorem 12.3. The lateral area of a regular pyramid equals half the perimeter of the base times the slant height. Theorem 12.4. The volume of a pyramid equals 1/3 the area of the base times the height of the pyramid.
Now it's time for a pop quiz.
What is the correct formula for calculating the lateral area of a prism? A. Lateral area equals pH. B. Lateral area equals area of base times height. C. Lateral area equals total area plus the area of a base. Yes, you are correct. The answer is A. Number 2. If the height of a regular square pyramid is 4 and the slant height is 5, what is the length of the base edge? A. 6, B. 4, or C. 10? You are correct once again. It is A, 6.
12.3 Cylinders and cones. A cylinder is a 3D figure with parallel congruent circle bases. Theorem 12.5. The lateral area of a cylinder equals the circumference of the base times the height of the cylinder, or lateral area equals 2 pi r/h. Theorem 12.6. The volume of a cylinder equals the area of the base times the height of the cylinder, or volume equals pi r squared h. Example number 1. Find the volume and the lateral area of a cylinder with radius 4 and height 6. The solution to the example is the lateral area of the cylinder is 48 pi, the volume of the cylinder is 84 pi. 12.3 continued. A cone is like a period with a circle for a base. The slant height of a cone is any line from the vertex of the cone to any point on circle base. Theorem 12.7. The lateral area of a cone equals half the circumference of the base times the slant height, or lateral area equals pi rl. Theorem 12.8. The volume of a cone equals 1/3 the area of the base times the height of the cone, or volume equals 1/3 pi r squared h. Example 1. Find the volume and lateral area of a cone with radius 3 and height 4 and slant height 5. The solution to the example is the lateral area of the cone is 15 pi and the volume of the cone is 12 pi.
12.4 Spheres. A sphere is a set of all points that are a given distance from a given point. Now, Theorem 12.9 states that the area of a sphere equals 4 pi times the square of the radius, or also denoted by A equals 4 pi r squared. Theorem 12.10 says that the volume of a sphere equals 4/3 pi times the cube of the radius, or also denoted by volume equals 4/3 pi r cubed.
12.5 Areas and volumes of similar solids. Similar solids are solids that have the same shape but not necessarily the same size. The picture below shows two similar pyramids. Since all squares are similar, the bases are also similar. 8/4 equals 10/5, which equals 12/6. Therefore, the pyramids are similar. The scale factor of the pyramids is 2/1. The next figure shows similar cylinders. The bases are similar because all circles are similar. The cylinders are similar because 6/4 equals 12/8. When you simplify 6/4, you get the scale factor, which is 3/2. Theorem 12.11 states that if the scale factor of two similar solids is a to b, then 1. The ratio of corresponding perimeters is also a to b. 2. The ratio of base areas, lateral areas, and total areas is a squared to b squared. And 3. The ratio of volumes is a cubed to b cubed. Now let's do an example. For both similar solids, find the ratios of A, the base perimeters, B, the lateral areas, and C, the volumes. Here are the answers. A, the ratio of the base perimeters is 3 to 5. B, the ratio of the lateral areas is 3 squared to 5 squared, or 9 to 25. C, the ratio of the volumes is 3 cubed to 5 cubed, or 27 to 125.
Another pop quiz! Yeah! Number 1. What is the lateral area, total area, and volume of a cylinder with radius 4 and height 3? A. 37 pi, 48 pi, and 50 pi. B. 24 pi, 56 pi, 48 pi. And C. 48 pi, 58 pi, 32 pi. You are correct! It is B. 24 pi, 56 pi, 48 pi.
Number 2. The area of a sphere is pi centimeters squared. Find the diameter of the sphere. A. 1 centimeter, B. 5 centimeters, or C. 2.5 centimeters. If you got A. 1 centimeter, then you are correct.
Number 3. What is the scale factor of two similar cylinders if the scale factor of the area is 9 to 16? Is it A. 2 to 1, B. 3 to 4, C. 27 to 64? If you got B, you are correct. It's 3 to 4.
Thanks for watching!